Hello everyone, my name is Mansa, pursuing BTech second year in Vasireddy Venkatadri Institute of Technology. Today I am going to discuss about Bowley's coefficient. So let me share a screen. Yeah, Bowley's coefficient. First of all, what is meant by Bowley's coefficient? Bowley's skewness is a way to figure out if you have a positively skewed or negatively skewed distribution. We know one of the most popular ways to find skewness is the Pearson mode skewness formula. In order to use it, you must know the mean, median, mode, and standard deviation for your data. Sometimes you might not have that information. Instead of that, you have information about your quartiles. So in that case, you can use Bowley's skewness as an alternative to find out more about asymmetry of your distribution. It is very useful if you have extreme values or if you have an open-ended distribution. We will see one problem regarding Bowley's coefficient of skewness. The problem is given as class intervals we have given as 5 to 10, 10 to 15, 15 to 20, 22 to 25, 25 to 30, 30 to 35, 35 to 40. And the frequencies corresponding to this class interval is given as 6, 8, 17, 21, 15, 11, and 2. Now we have to calculate the Bowley's coefficient of skewness for this following data. So first we will calculate the cumulative frequencies for the table. We will calculate cumulative frequency as first frequency we will write as it is, and next frequency we will write as cumulative frequency plus next class interval frequency. That is, for class interval 5 to 10, frequency is 6. So cumulative frequency is 0 plus 6 is equals to 6. For the class interval 10 to 15, the cumulative frequency is 6 plus 8 is equal to 14. Next, for class interval 15 to 20, the cumulative frequency is 14 plus 71, that is equal to 31. So we will calculate the cumulative frequency like this for the whole table. And we will mark the values, that is small f frequency, cumulative frequency CF, and lower boundary L. As it is, we know that small h is equal to width of the class interval. That is, we have width of the class interval as 5 here. So small h is equals to 5. First of all, we have to calculate the capital N value. We will get capital N value if we sum up the frequencies. So here, if we sum up the frequencies, we will get 80. So capital N becomes 80. Now we will calculate N by 2. N by 2 is equals to capital N 80, right? So 80 by 2 is equals to 40. We will check in the table cumulative frequencies values. 52 is just greater than 40, right? So it will become the median class. So the corresponding frequency becomes smaller value frequency of the median class, and lower boundary of the median class will become the L value, that is 20. Cumulative frequency means CF, how to choose the CF value from the table means CF means cumulative frequency of the class preceding the median class. So here 52, 20 to 25 is the median class, right? So 31 is the cumulative frequency value. As we know, small h is equal to width of the class interval, that is 5. So we will calculate the quartiles now. The lower quartile Q1 is given by Q1 is equals to L plus H into N by 4 minus CF divided by F. L means lower boundary of the median class, that is 20, plus small h means width of the class interval, that is 5, into N by 4. Capital N is 80, right? So 80 by 4 is equals to 20. 20 minus, we got here CF value as 31. So minus 31 divided by small f value. Small f value we have denoted the frequency of the median class as 21. So we will write here 21. If we calculate this, we will get 17.3809. This is the value of the lower quartile. Now we will calculate the median, that is Q2. Q2 is given by L plus H into N by 2 minus CF divided by F. As we all know, a small l is equal to lower boundary of the median class. Its value is 20 plus width of the small h, width of the class interval as 5 into capital N is 80, right? 80 divided by 2 is equals to 40. 40 minus, we got CF value as 31 divided by small f we got as frequency of the median class, that is 21. If we calculate these values, we will get 22.142. So the value of the Q2 is 22.142. Next, we will calculate the upper quartile. Upper quartile Q3 is given by Q3 is equals to L plus H into 3n by 4 minus EF divided by F. Small l is 20 plus small h is 5, width of the class interval, into capital N is 80. 3 into 80 divided by 4 is equals to 60. So 60 minus CF value is 31 divided by small f value is 21. If we calculate these values, we will get answer 26.904. Now, we will calculate the Bowley'S coefficient of skewness. The formula for Bowley's coefficient of skewness is given by KB is equals to Q3 plus Q1 minus 2Q2 whole divided by Q3 minus Q1. So we will substitute these values. We calculated just before, right? Q1, Q2 and Q3. So we will substitute Q3, Q1, Q2, Q3 values here, and we will substitute. We will calculate those values, and we will get answer as 0.0000945. It is the positive value. So the given table distribution table is positively skewed. We will conclude here as Bowley's coefficient of skewness is positive, so it is positively skewed. Thank you. Thank you for giving me this wonderful opportunity.